theorem. If G is a group, H a subgroup of G, and S is the set of all right cosets of H in G, then there is a homomorphism theta of G into A of S, and the kernel of theta is the largest normal subgroup of G, which is contained in G. If you just love watching proofs like this one's gonna be, subscribe to my channel. Okay, so the first thing I want to do is that and is a pretty big and in this proof. This here is going to be the second thing we prove. So if G is a group, H is subgroup, and S is the set of all right cosets, then there's their homomorphism phi that goes from G into A of S. So the first thing that we should do is define some of our mappings. How about we let T sub G, so let me say it this way. For some G in the group, let T sub G be a mapping from the set of all right cosets to the set of all right cosets be defined by this. Be defined by right coset acted on by tau sub G. This is just HXG. That's all it is. Okay. Now I'm going to show that tau sub G is in the set A of S. Okay. The first thing is I'll show 1-to-1. Suppose Hx is acted on by tau G, and the same thing for Hy. I guess I should say X and Y are in G. For X, Y, and G, that these two are equal. That's if and only if, that is by definition, HXG is equal to HYG. But we can cancel off their G's and we get HX equals HY. So we have 1-to-1. Now let's do on to. Let HY be in S, the set of all right cosets. So I want to find a right coset so that when tau sub G acts on it, I get back HY. And all you have to do is put in HG inverse, because that's YG inverse. That's going to be YG inverse times G. Associative law, this is Y times G inverse G, which is Y times E, which is Y. So we do have on to. Okay, now let's say G1, G2 be in G, and X is also in G. X acted on by G1, G2. This is just X, G1, G2. Well, let me not jump to it. G1, G2, but that's XG1 times G2. Those three elements X, G1, G2, they're all in the group G. Associative law follows. This here is nothing more than X times our G1. And this is just an element in G, and I'm multiplying it on the right by G2. That means it's this element acted on by tau G2. But that equals to X times tau G1, tau G2. Well, if this is equal to this, that implies that we have it. Tau G1, G2 is tau G1 times tau G2. And that's pretty good. This implies that okay, so as I was about to say, this implies that TG is in the set A of S for all X and G, and tau G1, G2 is tau G1, tau G2. What this tells us is the following. This implies that the mapping theta from G to A of S defined by theta of G is equal to tau sub G is a homomorphism. From G into A of S. A of S is the set or mappings of the right cosets of G. 1 to 1 and on to. Let me just get rid of this, please. Okay, so now what do we have to do? Well, in the last video we had a similar problem, and the next thing we did is we looked at the kernel. Okay, so what is the kernel of theta, which I'll call K for kernel? What is this? Okay, well, suppose I'll call it X. Suppose X is in the kernel. Then, no, I don't like X. Let's call it G sub 0. Then X tau G sub 0 must equal X, because this here is the identity mapping. And that's not true. I apologize. HX times G0 is equal to HX, because G0 is in the kernel. And by definition, HX tau G sub 0 is HX G0. This implies that HX is HX G0. I'm not going to do this, but if you let B in G be such that HB, no, HX, I'll say B here, is equal to HB, HX, that implies B is in kernel, which can be shown by following the process above. Just like G sub 0 ended up in the kernel, or how G sub 0 ended up in the kernel, or the consequence that G sub 0 is in the kernel, B is going to follow the same way. So this implies that the kernel theta, which I called K, is the set of all B in the set G such that HXB is equal to HX. Okay. So now, what do I want to say? Okay, so I did find the homomorphism theta from G into A of S. And did I actually state that? Yep, I did. This mapping from G to A of S is a homomorphism. So that's part A. That's the first part. Now we're starting the second part. We want to show that the kernel of theta is the largest normal subgroup which is contained in theta. Okay. Since K is the kernel of this homomorphism, that implies that K is normal in G. Now, sorry, yeah, normal in G. Now, why is it in H? Okay, so I'm going to show that K is in H. If B is in K, that implies that HXB is equal to HX for all X in G. For all X in G. That implies that HEB is equal to HE. But HE is H times B. And like I just said, HE is H. Well, if HB is H, that implies that B is in H. Well, B started off in K, it ended up in H. That implies that the kernel is a subset of H. Okay, just want you guys to read it again. The kernel of phi is the largest subgroup that is contained in H. So I showed that it's contained in H. There it is. Now I have to show it's the largest. So let N be a normal subgroup of G such that N is a subset of H. Now, what I want to show is that N is in K, and I already showed that K is in H. I want to show that every element in N is in the set K. Okay, so we know what things in K look like. So what I'm going to say is, okay, yeah, for all A and G, and say little n and n, we have the following. that A inverse is in N, because N is a normal subgroup. But that places, it's an element in there. That places this element in H. This implies that A inverse is an element of H. Well, that would mean that H times this element of H is equal to H. Multiplying both sides on the right by A, we get HAN is equal to HA. And this is for all A in the group. For all A in G. Just restating it. That implies that that implies that N is in the kernel. That implies N is a subset of H. I take that, well, that is true, but I mean to say that is a subset of K. That is, you have a group H, you have a subgroup of H, or you have a H and K are both normal subgroups. That's true. H is a subgroup of G. K is a normal subset of G, and K does lie in H. H contains K. Now, the only other way for a normal subgroup to lie in H is if it lies in or is contained in K. That makes K the largest subgroup that contains H. That completes this proof. As always, if you like watching mathematical proofs like this, seriously consider subscribing to my channel. Please click the like button. Tell your friends and family about my channel. See you guys in the next video. Watch and learn.